and welcome to the math story of Math 1, Unit 3, Systems of Linear Equations and Inequalities. I'm Karen McPherson, and I'll be your guide on this journey. In the previous unit, students wrote equations and inequalities to express constraints. They focused on algebraic, verbal, and tabular representations of these constraints. In this unit, students add graphical representations as a tool to continue exploring linear relationships. They analyze tables, graphs, words, and equations to identify and show the key features such as slope and y-intercept. Students will also build upon earlier work to create and solve systems of linear equations. This includes solving by graphing, substitution, and elimination. Lastly, students will create and graph linear inequalities and systems of linear inequalities. Let's take some time now to look at the progression of understanding across the unit. Take a moment to look at the sections of this unit. What do you notice, and what do you wonder? You may have noticed that the unit begins with students creating and reasoning with a single linear equation. This progresses to creating and reasoning graphically and algebraically with systems of linear equations. After the checkpoint, students create and reason with a single linear inequality and then progress to working with systems of linear inequalities. You may also be wondering about the number of additional lessons in the first section. Math 1 Grade 8 and Math 1 with Foundational Supports have 5 lessons as compared to 1 lesson for the Math 1 semester course. Let's take a closer look at this first section. Math 1 Grade 8 and Math 1 with Foundational Supports has 4 lessons that focus on writing 2 variable linear equations. The intent of these lessons is to introduce 8th grade students to the content they would have studied in 8th grade, and that is a critical prerequisite for the study of Math 1. These lessons are included in the Math 1 with Foundational Supports to revisit that critical prerequisite knowledge. Let's look at some of the strategies and representations used in these first lessons. As we do, you may want to pause the video to read the prompts and work the activities for yourself. This is Activity 1 of the very first lesson. Students are introduced to the Connecting Representations Organizer, also known as the CRO. The purpose of this organizer is to assist students in making connections between the 4 representations of linear relationships. It is intentionally placed within the first lesson's activities and will remain an optional tool for all students throughout the entire course. There are 2 key features associated with linear relationships: the rate of change and the initial value. The development of the vocabulary in these lessons is connected to the development of the concepts throughout the course. In 7th grade, students identified the unit rate and the origin as key features of proportional relationships. Building onto that idea is the development of a rate of change and an initial value. This is general vocabulary appropriate to a variety of relationships, not just linear. Yet since linear relationships have a constant rate of change, the vocabulary becomes more specific. The rate of change for a linear relationship is referred to as the slope. In the first 4 lessons of Math 1 Grade 8 and Math 1 with Foundational Supports, students first articulate how the rate of change and initial value are seen in each representation before incorporating precise language associated with those attributes for linear relationships, using words such as slope and y-intercept. The activity discussions provide the opportunity for students to use and develop precise language. So as you work through the lessons and plan for student engagement, pay attention to the development of these ideas and the development of the vocabulary itself. In this activity, students are going to calculate the rate of change between different intervals. This concept is revisited in Unit 5 when students study average rate of change of functions. In this case, students begin to see that a linear relationship has a constant rate of change, and this will lead them to call the rate of change the slope. The remaining lessons in this section provide students the opportunity to reason with different representations of linear relationships. Students identify the slope and y-intercept and write the equation of a line in slope-intercept form. In Unit 2, students wrote two variable equations in the form of ax plus by equals c, also known as standard form. They rearranged the equations into a y equals form with the purpose of being able to use the equation to evaluate for one variable if the other variable is known. Well, here in Unit 3, students will explore these equations further and develop an understanding of their graphs. It is in this unit that students come to understand that these equations are linear equations because the graph of the equation is a line. In this activity found in Math 1 Lesson 1 and in Math 1 Grade 8 and Foundational Supports Lesson 5, the students start by calculating the cost for different combinations of pounds of chicken tenders and pounds of potato wedges. This activity prompts students to notice and represent repeated reasoning. The activity continues by asking students to consider if a combination is possible. Next, they consider different combinations that would total $75. Lastly, students write the equation. The focus on different combination is building towards an understanding that the graph is the set of all solutions to the equation. The next activity asks students to find combinations that are solutions to the equation. This is similar to work that they did in Unit 2. And make the connection to the coordinate pairs on the graph of the line. This understanding will be important later in the unit when students are considering solutions to the systems of linear equations and solution regions for linear inequalities. The next section of the unit is manipulating equations and understanding their structure. Here, students learn to write and graph linear equations in different forms: standard and slope-intercept. They also see that the different forms make different features of the graphs most apparent. Let's take a look at these two ideas. In the activity, Graphing Games and Rides, students are using reasoning similar to what they used in the previous lesson. They are asked to find a combination that is a solution to the equation. The combination in this case is strategic. They are asked to find the value if one of the variables is 0. In this case, if the student doesn't play any games, then the combination is 0 and 7. If the student doesn't ride any rides, the combination is 28 and 0. Students can graph the line using these 2 points. Students conclude that the intercepts can be quickly identified if given standard form by being strategic with what value they use to substitute into the equation. In Unit 2, students had learned to rearrange an equation. They applied this understanding to rearranging standard form into y equals form. In this activity, they make the connection that when rewritten into form y equals mx plus b, the slope and the y-intercept can be quickly identified. This takes us into the third section of the unit, Systems of Linear Equations in Two Variables. Students build upon what they've done in the previous 2 sections, writing and graphing linear equations. They do this to solve systems by graphing. They build upon the work in Unit 2, creating and solving one-variable equations, to solve by substitution. And then students develop a third way to reason with systems that includes adding and subtracting equations and multiplying by a scalar to solve by elimination. Students have learned to graph linear equations by hand in simple cases. They have identified key features from standard and slope-intercept form. So as students transition into solving systems by graphing, they begin to use graphing technology such as Desmos. The focus of the activities within the lesson are in writing the systems and interpreting the solution. Visual models are used to help students make sense of the algebraic methods. For example, in the launch, before solving by substitution, students participate in a notice and wonder routine with this diagram. How might this diagram be used to help students think about solving by substitution? How can the diagram be expressed as a system? In both cases, the 8 can be substituted into the second equation, which we can then conclude that y equals 7. Solving the first equation gives us x equals 8/3. Therefore, the solution to the system is 8/3 and 7. As students approach learning about elimination, hanger diagrams give students an intuitive and concrete way to think about combining two equations that are each true. These balanced hangers suggest that the weights on the two sides of each hanger are equal. Each side of the hanger on the right shows the combined objects from the corresponding side of the first two hangers. Students can reason that if two circles weigh the same as one square, and one circle and one triangle weigh the same as one pentagon, then the combined weight of the three circles and one triangle should also be equal to the combined weight of one square and one pentagon. Students first solve by combining the equations of the system by adding or subtracting the equations. The systems are intentionally designed to allow for elimination of one of the variables through addition or subtraction only. Next, students look at systems that require one of the equations to be multiplied by a factor before combining to eliminate a variable. This connects back to Unit 2, where students articulated the acceptable moves for producing equivalent equations. The sections after the checkpoint lesson are very similar to the sections prior. Students first explore a single two-variable linear inequality, followed by systems of linear inequalities. Let's look at the section for a single linear inequality. In a previous lesson, students developed an understanding that a point on the line is a solution to the equation. In this activity, students interpret the coordinate pairs of points on either side of the graph of the line. Students are asked to determine if the point 600, 200 satisfies the constraint. They also look at the point 200, 100 and determine if it satisfies the constraint. They then use these observations to speculate that the solution to a two-variable inequality is a region in the coordinate plane. This strategy is very similar to how students reasoned with identifying the solution set for a one-variable inequality in Unit 2. Earlier in the unit, students solved systems of linear equations in two variables. They also found solutions to linear inequalities in two variables. In this section, students build upon those understandings to find the solutions to systems of linear inequalities in two variables. In this activity, students encounter a situation in which two constraints that can be expressed with inequalities are represented on two separate graphs, making it challenging to find pairs of values that meet both constraints simultaneously. This motivates a desire to represent both constraints on the same graph. Once students have learned that any point that is in the overlapping regions of the graphs is a solution to the system, they take a closer look at whether points that are on the boundary lines are solutions to the system. Again, the strategy is by testing points to see if they satisfy the constraints. As we wrap up this math story of Unit 3, Systems of Linear Equations and Inequalities, let's take a quick look at the public records that will help students track their learning throughout the unit. The representations of a linear relationship is specific to those additional lessons found in Math 1 Grade 8 and Math 1 with foundational supports. The next two public records focused on solving systems of linear equations algebraically, And the last public record is for graphing a single linear inequality. This concludes the math story of Unit 3, Systems of Linear Equations and Inequalities. Thank you for all you do to support students in learning Math 1.